Friends, so this is the chemistry class number 51 and today I am going to take 17 group elements in P block elements. You see, 17 group elements are also called the halogen family elements. You see, we know that in the 15 group elements, the elements are called the nitrogen family. In the 16 group elements, they are called the oxygen family, and 17 group elements are called the halogen families. We are all having halogens here. You see. So what are the halogens? You know, and which is the most electronegative element in the periodic table, you see. So that is fluorine. So let me write the important halogens here, you see. So that is fluorine, chlorine, bromine, iodine and astatine. So that means important halogens are fluorine, chlorine, bromine, iodine and astatine. So these are the that is 5 halogens we are going to have in the halogen families. So that means 17 group elements are also called the halogen family elements. What is the meaning of this halogen means? So halo means salt, actually salt. Gens means producers. So therefore halogens are nothing but the salt producers. Therefore halogens are also called salt producing elements. Salt producers, they are called the salt producers. So after that you see, generally what is the general electronic configuration of the 17 group elements? You see, that is noble gas, NS2, NP5. So that means NS2, NP5. That means outermost electrons. That is outermost shell contains valence shell contains that is 7 electrons. Valence shell contains how many electrons? 7 electrons. So therefore these elements are active because they are eager to take one more electron. You see, they are eager to take one more electrons to get octet structure. So for this reason, you see, so generally all halogens will exhibit -1 oxidation state. You see, all halogens exhibits which oxidation state? -1 oxidation states because they gain 1 electron to complete their octet structure to get 8 electrons in their octet structure. So that is valence shell. So let me write this. For example, X. So this is halogen plus 1 electron. You will get X minus P. That is NS2 NP5 plus 1 electron. You will get NS2 NP6. So this is octet structure. So therefore, all halogens exhibits -1 oxidation states. You see, -1 oxidation states. So let me write that is the electronic configuration of all these elements first. After then we will have the oxidation states also. So that means you see, now 17 group elements will have the general formula. That is noble gas NS2 NP5. So therefore valence shell of halogen family contains how many electrons? So that is 7 electrons, and p orbital contains 5 electrons. So therefore let me write that is electronic configuration for all these elements now. You see. So that is first one is that is fluorine, that is 9, is atomic number 9. So therefore helium, that is 2 elements, 2s2 2p5 is 2s2 2p5. So that means helium 9, that is fluorine 9, helium 2s2 2p5. Helium means 2 electrons, 2 plus 2 4 plus 5 is 9. So that is chlorine 17, we know 17. So these are 17 means you take neon, that is 10. So there is 3s2 3p5 is 10 plus 2 12 plus 5 17. Okay. So that is bromine, that is 35 is 35. So that is argon. For example, argon is 18. You know, that is 3d10 4s2 4p5 is 4p5. So that is 18 plus 10, 28, 20, 35. So that is how we can write that the electronic configuration for bromine 35, argon 3d10, 4s2, 4p5. So that is iodine is 53. You see, just reverse this. You will get it. This is 35. This is what? 53. So that is argon. That is krypton 36. So this is 4d10, 5s2. 5p5. So you have 36 plus 10, 46, 50, 55 is 55. That is krypton. That is this is 53, of course. krypton 36, 10, 46, 46, 48. 48 plus 5 is 53, correct? Not 55, it is 53. 36 plus 10, 46, 48, 53. Okay. So astatine is, of course, it is 85. You see, 85. So here you have to take xenon 54. You see, xenon 54. So here 4f orbital coming to exist here. 4f14, 4f14. So that is 5d10, 5d10, 6s2, 6p5 is 6s2, 6p5. So that means this is 54. 54 plus 14 is 68, 78, 80, 85 is. So this is how we can write the electronic configuration for your that is 17 group elements: fluorine, chlorine, bromine, iodine, astatine. So fluorine 9, helium 2s2, 2p5, fluorine 17, neon 3s2, 3p5, bromine 35, argon 18, this one, and 3d10 4s2, 4p5, iodine 53, krypton 36, this one, 4d10 5s2, 5p5. So astatine 85, xenon 54, 4f14, 5d10, 6s2, 65. Here you see, you can observe in all these elements, you see, valence electron, that is last valence shell contains only 7 electrons, you see. 2 plus 5, 7, 2 plus 5, 7, 2 plus 5, 7, 2 plus 5, 7, 2 plus 5, 7. That means you see, in almost all the that is halogen family elements contains how many valence electrons? 7 valence electrons in its valence shell. So therefore, it is always they are always eager to take one more electron to pair up and to get octet structure. You see, 8 electrons is called the octet structure. It has 7 electrons. Therefore, for this reason, you see, all the elements exhibits a -1 oxidation state. Okay. So this is electronic configuration of 17 group elements. So after this, let me take the oxidation state. Oxidation state of your halogen families. So as earlier I have told that you see all halogens exhibits -1 oxidation state. All halogens exhibits what? Minus the common oxidation state of halogens is -1. All halogens exhibits -1 oxidation state. So due to the fact that you see they gain 1 electron to get one more complete octet structure, you see, that is X plus 1 electron gives rise to X minus hydrogen, that is Cl. So like that is for example NH2 NP5 outermost electron plus 1 electron will getting NH2 or NP6. For example, if you take this chlorine, Cl plus 1 electron will getting Cl minus. That means you see Cl means how many electrons are? How many electrons? 17. 17 plus 1 electron will get how many? 18 electrons. 18 electrons. So you can write the electron configuration for this also, you see. 17 means you see that is 1s2 that is helium, neon, that is 3s2, 3p5, that is neon means 10 electrons, 10 plus 12, 12 plus 5 is how much? 17 plus 1 electron you will be getting finally. So this is neon, 3s2, 3p6 you see, 3p6. So this is how all the halogens are eager to take one more electron to complete its octet structure, you see. So therefore they exhibits -1 oxidation state. Almost all the halogens exhibits -1 oxidation state. So after that you see generally this Cl, Br and I. So remember Cl, Br, I, that means chlorine, bromine, iodine exhibits +1, +3, +5 and +7 oxidation states in different excited states, you see. Which elements? Remember Cl, Br and I. Chlorine, bromine, iodine exhibits +1, +3, +5, +7 oxidation states in different excited states, you see. Ground state and you know the excited state as well as the ground state. So electrons in the ground state of an atom. So that is called the ground state. If the electrons are jumped from a lower level to higher level, it is called the excited state, you know. So let me write the plus 1, plus 3, plus 5, plus 7, how actually the oxidation states are obtained. Okay. So let me take the halogen in the ground state, please. So that means you see plus 1, plus 3, plus 5 and plus 7. So these are the 4 states we are going to that is considered for CL, Br, using. So any halogen, you know that you see any halogen in the ground state, that is halogen X in ground state, ground state. How do you write? That is NS2 NP5. This is NS2. NP means you see how many that is shells are there? 3. NP, that is 5. NP5. That is 1, 2, 3, 4 and 5. So this is NS2 NP5. And here there are some vacant DRBs are there is ND orbitals 1, 2, 3, 4 and 5. So that means you see 1, 2, 3, 4, 5. DRBs are 5. That means you see 1, 2, 3, 4, 5. Okay. So here this is vacant now. Now at this time you see it is vacant because it is ground state. So here how many where that is unpaired electrons are there? Only one electron, only one. So therefore you can write that is plus 1. So that is plus 1 indicates that is sorry, one unpaired electron. Let us say one unpaired electron indicates plus 1 oxidation state in the ground state. So this one unpaired electron indicates plus 1 oxidation states. Okay. So now it is the ground state. So first excited state. Let me write first excited state. Excited state. I am going to write. In the first excited state, so what happens here? See, from NP5, one electron will jump from p orbital to d orbital like this. One electron. So then what happens? So this becomes NS2 as usual. NS2. It should be as usual. NS2. And then in the NP3, you see 1, 2, 3. 1, 2 electrons are here. But here only one electron. One electron jumps to this position. So this is also one electron. So and in this ND orbital, what happens? You see 1, 2, 3, 1, 2, 3. 3, 4 and 5. So that means one electron jumps from this to this level you see. That means it becomes NP1. It becomes NP4 you see. 2 plus 2, 4. So here you see how many unpaired electrons here? In all these 3. 1, 2, 3 you see. So therefore 3 unpaired electrons. That is indicates plus 3 oxidation state. So 3 unpaired electrons in these orbitals indicates what? Plus 3 oxidation state. So it is in the first excited state. Let me write the second excited state. So that is second excited state. In the second excited state you see. So again one electron from NP4 level should that is transferred to ND level you see. So to this, from this level, so this level to this level. Okay. Now let me write the same thing again. Here NS2 orbital. This is NS2. In the NP orbital, how many electrons are actually present? Only 3 you see. 1, 2, 3. 1. Why? One electron jumps to this position. So we will be getting like this. 1, 2, 3, 4 and 5. This is the electron, this is the electron. So that means you see how many valence unpaired electrons are there? 1, 2, 3, 4, 5. 4 unpaired electrons. Therefore, oxidation state is equal to 5 is it? Not 4 or 4, it is 5. 1, 2, 3, 4, 5. Therefore, 5 unpaired electrons. 5 unpaired electrons. Therefore, for 5 unpaired electrons indicates that is plus 5 oxidation state. So this is how you can write. So at the third excited state, you see, third excited state, what happens here? So now from ns level also one electron transfers you see to this position. Okay. So what happens? You can write the excited state again. That is ns2. That is only one electron you see. Now this is 3 electrons as usual you know. That is 1, 1, 1. But here you see the ND 1, 2, 3, 4 and 5. 1 electron, 2 electron, 3 electron. This is ND3. This is ND2 you see. ND2, this is ND1. So this is NP3 of course. It is NP3. It is also NP3. Now you see in this third excited state actually what happens? All the electrons are singly that is paired you see. 1, 2, 3, 4, 5, 6, 7. How many electrons are there? 7. So therefore you see 700 electrons. 700 electrons indicates plus 7 oxidation state. Plus 7 oxidation state. Plus 7 oxidation state. Okay. So this is how you can explain the oxidation state of ClBrI. It seems to be plus 1, plus 3, plus 5, plus 7 in different excited states. Also it is 100 electron exhibits 1 oxidation state. It is plus 3 oxidation state. It is plus 5 oxidation state. It is plus 7 oxidation state. Okay. So this is the oxidation states of your ClBrI in the different excited states. So after that, what is that is oxidation states of your fluorine using. So fluorine can exhibit only plus 1 oxidation state only. Minus 1 oxidation state. So because you see it does not have any, it is a smaller atom one and it is most highly electronegative element in the periodic table, and in there is a bond dissociation enthalpy between F and F is very very low you see. The bond dissociation enthalpy between F and F is very very low. So due to the repulsion between the 2p orbitals, so therefore it exhibits only minus 1 oxidation state. It does not exhibit even plus 1 oxidation state you see. Okay. So due to the repulsion between the orbitals of that is 2p orbitals in F and F atoms you see. So therefore it exhibits only minus 1 oxidation state. It does not exhibit even plus 1 oxidation state you see. So that is and of course it is one reason. Another reason it is a smaller size atom and high electronegative element. It is high electronegative element and due to smaller atomic size, so it does not exhibit. So that is plus 1 oxidation state also. So next, why the other elements can exhibit plus 3, plus 5, plus 7 oxidation states? That means you see the other elements like Cl, Br, I, As, etc. exhibits higher oxidation states. So it is due to the fact that you see, so these elements combines with the smaller electronegative, highly electronegative elements as well as smaller atoms you see. So that means the higher oxidation states of the other elements is due to the fact that so these other elements so combines with the high electronegative and the smaller atoms like oxygen and fluorine you see. Oxygen as well as what? Fluorine. So for this reason you see they can exhibit higher oxidation states, that is plus 3, plus 5, plus 7, etc. So and for examples you see interhalogens, the compounds like interhalogens. What is interhalogens? IF7. Let us say ClF5, IF7 let us say. Like this you see, so these are called the interhalogens. Even oxoacids like HClO, HClO2, HClO3, HClO5, HClO4. Like this you see. So oxoacids are also formed with higher oxidation states you see. Okay. So for example you see you can calculate Cl you see. So that is 1 plus x minus 2 is equal to 0 you see. Therefore x is equal to 2 minus 1 is 1. But here what happens you see 1 plus x minus 4 is equal to 0. So that is what is x? X that is 4 minus 1 is equal to how much? 3 here. Okay, 3. But here you see that is 1 plus x minus 6 is equal to 0 for this. So it is x that is x is equal to 6 minus 1 that will be equal to how much? 5 you see. It is 5. It is 3. Like this you see, oxidation state will be decreases. Okay. So next, after this you see, we have one concept which is trends in physical properties. You see. Trends in physical properties. Trends in physical properties. Trends in physical properties. So you know that you see trends in physical properties are nothing but that is we have already discussed in the previous that is classes. That is atomic size. One is atomic size. So then that is your ionization enthalpy. Ionization enthalpy, it is also called the what? Ionization potential. And then electronegativity. So these are the important aspects to be discussed with respect to trends in physical properties. So generally atomic size you see, we know that you see, so that is different F, Cl, Br, I, Ab. So as you go down from fluorine to acetylene, the atomic size will be increases. Generally the atomic size of all the halogens increases from fluorine to what? Acetylene. So due to the that is decrease in the your effective nuclear force. There is a decrease in the what? Effective nuclear force. That means you see, at every time new shells are added. So this is another reason you see. At every time new shells are added. As the shells are added, disease size will be increases. So there is control for the increase in the size you see. Why? Because you see, effective nuclear force will be decreases. The nucleus does not have any command over the outer electrons to attract towards itself. For this reason, you see, as the atomic number increases, every time new shells are added, the effective nuclear force will be decreases. Therefore, the atomic size will be what? Increases. That is the first factor. Second factor, you see, ionization potential. You know that you see, ionization potential or ionization energy, it is the amount of energy required to remove the outermost electron. What is the ionization energy? It is the amount of energy. It is the enthalpy required to remove the outermost electron of an atom. You see, outermost electron of an atom. Let me tell this. This is the atom. This is the outermost orbit of an atom. So it contains last electrons. So as the atomic number increases, atomic size also increases. As the atomic size increases, you see, the outermost electron is far away from the nucleus. When the electron is far away from the nucleus does not have any that is controlled over the outermost electron. So therefore, you can knock out the electron easily by giving little amount of energy. That means you see, ionization enthalpy decreases. Ionization enthalpy decreases, but atomic size increases. You see. So ionization enthalpy decreases down the road because as the atomic number increases, atomic size increases. Okay, effective nuclear force will be decreases. The nuclear force on the outermost electron